Okay, so moving on with our inequalities, today we're going to talk about solving and graphing compound inequalities. And there's two types of compound inequalities. There's the and problems, and there's the or problems. So an or problem is really going to be two separate inequalities. Like you might say something is less than 2 or greater than 10. So you have two separate inequalities that you'll solve and graph. Or sometimes you're going to say and if something has to meet two parameters. So maybe in order to participate on a certain ride or something, you have to be greater than a certain weight and less than a different weight. So for example, if we went to a water park, in order for a certain slide to operate properly, the people on the ride, there has to be a weight range, right? So you have to be heavy enough to ride the ride, but it also can't be too heavy with the amount of people. So maybe everyone gets on the scale together and the weight has to be greater than, let's say, 200 pounds and less than 400 pounds, let's say. So somewhere in there. So when it's an and problem, typically your x is going to be in the middle of a lower value and a greater value. So you'll end up writing your answer as one inequality with the x or the variable in the middle. And when you do it like that, the smaller number will always be on the left and the larger number will always be on the right. And your inequality signs will always be less than signs. So I always think of a less than sign at the symbol kind of looks like the letter L, and that's how to remember it. And then the or problem, it's just like two separate inequalities. So let's write and graph a compound inequality. So if we're looking at this one here, it says all real numbers. So when you see this, that's telling you that's your variable, okay? Because the x is going to represent all the real numbers that are less than or equal to 7. So x is less than or equal to 7, or it could be greater than or equal to 10. So notice, even though it just said all real numbers once, I saw the or, so I knew I was going to have two separate problems. So I did all real numbers that are less than or equal to 7, or I did all real numbers that are greater than or equal to 10. So I had my two separate inequalities. Now the first one here, x is less than or equal to 7, is represented by the filled in circle at the 7 going to the left. The second inequality here, the x is greater than or equal to 10, is the solid circle at the 10 and then going to the right. So each of the two inequalities is represented by the two sides. Now another way you can kind of check this is if you're good at graphing, I always say that when it's an or problem, if you imagine yourself on a boat, like a little rowboat or something, sorry, I'm not an artist, but you would have the little oars going out on the sides of the rowboat, right? So that is another way to remember an or problem. The two shadings on the graph are going to be like little oars on a rowboat. Okay, so here's another one. Now this time we're going to look at an and problem. Okay, so again, it says all real numbers, so we know that that's just telling us that we have a variable, are greater than -1 and less than or equal to 1. So when I set these up, I do it a little bit differently because as soon as you see the word and, you know you're going to have an x in the middle. And every time you have an x in the middle, if you always put the smaller number on the left and the larger number on the right, your symbols will always be facing the same direction. 100% of the time, they're always going to be less than signs if you put your smaller number on the left, which in this case is -1, and your larger number on the right, which in this case is +1. Now, the only thing you would have to check is, do you need an equal to underneath either of these? Greater than -1. So the one by the -1 did not have an equal to. Less than or equal to +1. So this one would need the equal to. So this would be our answer. So this is actually incorrect. Should have a line there. Okay, now this is going to be the opposite situation as the or problem that we saw where the two shadings were on the ends, or they were like little oars on a boat. In this case, since X is in the middle, you're going to be shading in the middle of these 2 points. So -1 was an open circle, +1 should have been a closed circle. And then we would be shading in the middle because X is represented by any of the numbers that are in the middle or in between those two values. Okay, translate the verbal phrases into an inequality, then graph. So first thing you want to do is look for either the and or the or. So typically, sometimes there can be the word or the word and used multiple times in the sentence, and that can get a little bit confusing. So if you're trying to say, less than or equal to, that's an or, but then there also could be an or indicating it's a compound inequality, and that can get a little bit tricky. So a lot of times they will use italics, which is just a different font, kind of like a little bit of a curved font to demonstrate that it is a compound inequality. So this is the or and this is the and. You can kind of see there's a slight different font being used there. So since this is an or problem, I know I'm going to have two separate inequalities. So all real numbers that are less than -3, so that would be X is less than -3 or greater than 0. So then I would have to write X is greater than 0. So you can see I've represented my two different inequalities. Now again, since this is an or problem, I'm going to have little ors on my graph here, right? Now, in the past, when we were graphing, we only needed the number that was in question, right? So that dividing number. So if we were just saying like X is greater than 2, all we cared about on our number line was the 2. But now we have two separate numbers, so we need to make sure they're both on there. And it's a good idea to have the numbers in between them, if there's not too much space, also kind of marked out so we can sort of get a good visual of how far apart these numbers are. So -3 is over here, and that was an open circle, and we'd be shading to the left. And then the other one here, X is greater than 0, so an open circle at 0, and I'd be shading to the right. And then my graph does look like two little oars sticking out on either side of a boat, so that's a good sign. Now my next question has an and. So this time when I set up my inequality, I'm going to put an X in the middle, and I'm going to just start out with two less than signs. Then I'm going to look for the two numbers in the problem. All real numbers that are less than 9 and greater than or equal to 7. So the first thing I want to do is just identify, well, what are the two numbers? And 100% of the time, you want to put the smaller number, which in this case would be 7, on the left, and the larger number in this case is 9 on the right. So you always want the smaller number coming first, the larger number coming second. That way you always know your signs are pointing to the left. They're less than signs. Now you just have to check, do I need an equal to on there? Less than 9, so this one was just less than 9. I do not need an equal to. Then the other one said greater than or equal to 7, so I do need the equal to. Now you might be like, wait, it says greater than, I'm confused. Don't be confused, because that would be if we were reading this backwards. X is greater than or equal to 7. But like I said, you don't need to worry about that. If you always have the smaller number on the left, the bigger number on the right, the signs will always face the same direction like this. They're always going to be pointing at the little guy and opening up or eating towards the bigger number. Now, when we go to do this one on the number line, it makes sense, because if you were writing your numbers out, 7, 8, 9, that's the order they would go in, right? So the smaller number would be on the left, the bigger number would be on the right, and we would be shading in between. We'd be saying X is greater than or equal to 9, but it's also greater than or equal to 7, but it's also less than 9. So it has to be a number in between there. And then finally, let's do the third one. Again, there's an or problem happening here. So all real numbers that are greater than or equal to 14. So that's one of my inequalities. X is greater than or equal to 14, or less than or equal to 10, less than or equal to 10, and I'm going to just need another X there since it was an or problem. Then I know that when I graph this, all right, so this time they may not be, may not be the smaller number on the left. So you're just going to make sure you have a 10 and a 14 on your number line. So here's my 10. Then I'm going to go in order 11, 12, 13, and 14. So the first inequality I had was X is greater than or equal to 14. So that'd be a closed circle at the 14 going to the right. My second inequality was a closed circle at the 10 going to the left. So how do we solve these? Well, solving an AND problem, typically we have our variable in the middle. So when we solve one of these, we essentially want to get the variable by itself in the middle. So if I needed to move this 4 here, I'm going to not only add it to the middle to cancel it there, but I'm going to add it to the right and add it to the left. So that's what you can see here. Then we end up with 11, X in the middle, and 12 plus 4 is 16 over here on the right. But my signs did not change because just like in earlier lessons, the only time you reverse your signs is if you multiply or divide by a negative. We just added 4. So now my X is by itself. So I have 11 is less than or equal to X, which is less than or equal to 16. When I go to graph this on the number line, I'm going to want to make sure I have the 11 and the 16. And if there's a few numbers in between, these would both be closed circles since we have the equal to lines, and I would be shading in the middle. So let's try another example. So for this one here, I want to get this X by itself in the middle. So first I'm going to subtract the 3, but you have to make sure you do it to the left, the right, and the center. So 9 minus 3 is 6. I still have that same inequality sign there. I still have a 2x in the middle, another inequality sign, and 15 minus 3 is 12. Still working on getting this x all by itself. This time, though, 2 times x, the inverse operation is division. So everything's going to get divided by 2. This leaves me with 3 is less than x is less than 6. So this would be the answer to my inequality. Now when I go to graph this on the number line, here's 3, 4, 5, and 6. I want to have open circles at both my 3 and my 6, and I'm shading in the middle because x is in the middle of those two values. Okay, so then doing number 5, we're going to add the 12. We're working towards getting the x by itself in the middle. So 30 plus 12 is 42. I still have negative 7x in the middle. And 16 plus 12 is 28. Now I'm going to divide by negative 7. Now watch what happens here. Just like before, when we divide or multiply by negative, we switch our inequality signs. So this 42 divided by negative 7 is negative 6. And in the middle, I have x. 28 divided by negative 7 is negative 4. But notice these two inequality signs are going to be reversed. And you'll notice that that worked out quite nicely because now the smaller number, which is the negative 6, is on the left. And the larger number, which is actually just that negative 4 there, is on the right. So I'm going to need a closed circle at the negative 6, since I have the equal to line, an open circle at the negative 4, and I'm going to shade in the middle. These. So this time I want to distribute to get rid of those parentheses in the middle. So 4 times 2 is 8x, and 4 times the 3 is the 12. Now we're going to work on getting this 8 isolated. So we're adding 12 to both the center, the left, and the right. So I have 40 is less than or equal to 8x, which is less than or equal to 80. Everything is getting divided by 8 to get my x alone. So I have 5 is less than or equal to x, which is less than or equal to 10. So when I go to graph this on my number line, I need a 5, 6, 7, 8, 9, and 10. Close circles at both my 5 and my 10, and I'm shading in the middle. All right, now solving a compound inequality with an OR is really simple because it's just like doing two small separate problems. You just put both of the graphs on the same number line, and they should be on the two ends like little oars on a boat. So in this example here, the first problem, 3x plus 4 is less than 16. We subtract the 4, divide by 3, and we have our first answer. Then the second inequality, you would add the 12, divide by 5, you get your second inequality. And of course, then you would go to graph them. So x is less than 4, open circle at the 4, going to the left. X is greater than 5, open circle at the 5, going to the right. Okay, so here's an OR problem. I'm going to separate it and solve them individually. So the first problem, or the first half here, I'm going to do 3x is greater than 18, dividing by 3, and I get x is greater than 6. Then I'm going to do the other side, having nothing to do with the first side I did, subtracting 4. I have negative x is greater than 11. And then I have to divide by that negative 1, keeping in mind that you need to reverse your inequality sign. So now this means I have x is greater than 6 or x is less than negative 11. So when I go to do this on my number line, I want negative 11, negative 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6. And you could just go by like 5s or 2s or something like that just to make it fit a little better if you need to. Open circle at the 6, going to the right, and an open circle at the negative 11, going to the left, noticing that my graph, the two shaded parts do look like little oars on a boat. Okay, so then the next example, again, is an OR problem. So we're just doing two separate problems, but graphing them together. Half times x plus half of 18 is 9. Subtracting the 9. 1/2 x is greater than negative 3. And then I'm going to multiply by my reciprocal to get that x by itself. So I end up with x is greater than negative 6. Or, let's see what happens on the other side. Subtracting the 5. 7x is less than negative 56. Divide by 7. X is less than negative 8. So when I go to put these on my number line, I'm going to have a negative 8, negative 7, and negative 6. That's really all I need. X is greater than negative 6, so open circle going to the right. And x is less than negative 8, open circle going to the left. Notice this is an OR problem, and my two shaded parts of the graph look like oars on my boat. And then finally, let's take a look at number 9. So again, another OR problem. So I'm separating these. All right, so I'm going to just bring my x over to the left here, but if you wanted to subtract the 3, that would work too. So negative 4x plus 8 is greater than negative 12. Subtracting my 8. Negative 4x is greater than negative 20. I just now have to divide by negative, which is going to flip my inequality sign and give me x is less than 5. On the other side of the problem, I have 9x minus 18. I'm going to subtract my 8x over to the left, giving me x minus 18 is greater than negative 9, adding my 18. So x is greater than 9. Okay, when I go to my number line, that tells me I've kind of done this correctly, I have a 5, a 6, a 7, an 8, and a 9. So less than 5, x is less than 5, will be an open circle going to the left, or x is greater than 9, again, an open circle going to the right.